Data distribution can be presented to ungrouped data and group data. Okay, there are two types of ungrouped data, which is first raw data and second ungrouped frequency data. Okay, for group data, the data can be organized into limits or boundaries. In this video, we shall discuss the measure of central tendency and measure of position for raw data. Measure of central tendency can be either mean value, median value, and model value. Okay, from these values, we can identify the shape of distribution. Measure of position, quartiles, which is divided into 4 equal parts. First quartile or lower quartile, second quartile or also known as median, and third quartile or upper quartile. Okay, from quartiles, we can draw a box plot. The formula and steps to find the mean, median, quartiles, and mode. Okay, for mean, we use formula summation x divided by n, which is total of observation divided by number of observation. For median or quartiles, first step, arrange data in ascending order. Second, find the position. If we want to find the first quartile, the position of first quartile is n plus 1 divided by 4. For median or second quartile, the position of second quartile is n plus 1 divided by 2. And for the third quartile, the position is 3 times n plus 1 divided by 4. And then locate the quartiles from the arranged data and hence determine the quartiles value. For mode, the model value is the most frequent value occur. Okay, now we look at the example. The data below show the marks of 10 students in an accounting test. Calculate the mean, median, and mode, and hence determine the shape of data distribution. First, to find mean, we use the formula summation x divided by n, which is we have to total up from the first observation until 10 observations and then divide by 10. So the mean value is 64.6. Therefore, the average marks of 10 students is 64.6. For median, we arrange the data in ascending order and then find the position of median, which is 10 plus 1 divided by 2 equals to 5.5, meaning that the position of median is between 5th and 6th. So the median value is 66 plus 70 divided by 2 equals to 68. Therefore, 50% of the students have marked less than 68 and another 50% of students have marked more than 68. For model value, we have to identify the most frequent value occur. Okay, based on this data, we see that 70 occurs 3 times. So, the mode is 70. Therefore, we can conclude that the most of students have marks 70. And then determine the shape of data distribution based on mean value, median value, and model value. So we can say that the distribution is skewed to the left because mean value is less than median value. Next, calculate the first quartile and the third quartile for the given data. For the first step, we arrange the data in ascending order. So the first quartile, first find the position of the first quartile, which is 10 plus 1 divided by 4 is equal to 2.75. So the position of the first quartile is between second and third position. In order to find the first quartile, the second position, which is 50 plus 0.75 times the difference between second and third position. So the first quartile is 53.75. This means 25% of the students have marked less than 53.75 and another 75% of the students have marks more than 53.75. Next, for the third quartile, find the position of the third quartile, which is 3 times 10 plus 1 divided by 4 is equal to 8.25. So the position of the third quartile is between 8th and 9th position. So the third quartile is 70 plus 0.25 times the difference between 8th and 9th position. So the third quartile is 71.25. This means 75% of the students have marks less than 71.25 and another 35% of the students have marks more than 71.25. The formula of interquartile range IQR is third quartile minus first quartile, and the formula for interquartile deviation is IQR divided by 2. Okay, now we look at how to sketch a box plot. Okay, first we have to identify the smallest value and the largest value. Based on this example, the smallest value is 45 and the largest value is 80. Okay, this is important in order to estimate the scale. Okay, and then we have to find the lower quartile and upper quartile. Based on these quartiles, we draw a box length that extends from first quartile to third quartile. Okay, and then draw a vertical line in the box that show the median value. Okay, then draw a horizontal line from smallest to largest value. Okay, this line is called whiskers. Okay, from the previous slide, we have found the interquartile range IQR. Okay, the IQR value is show the difference between first quartile to third quartile. Okay, from the box plot, we also can identify the shape of distribution. Okay, there are two parts between the median line. Okay, so since the left part is bigger than the right part, okay, this show this distribution is skewed to the left. Next, we look at the example if the number of observation is an odd number value. Find the lower quartile, median, and the upper quartile for the given data. First step, we have to arrange the data in ascending order. So for the first quartile or lower quartile, find the position, which is the position is 9 plus 1 divided by 4 is equal to 2.5. Meaning that the position of first quartile is between second and third position. So the first quartile is equal to 14. And then for the median or second quartile, the position is 9 plus 1 divided by 2 is equal to 5. So the median or second quartile is 14. And the last one for upper quartile, the position of third quartile is 3 times 9 plus 1 divided by 4 is equal to 7.5. So the position of third quartile is between 7th and 8th position. So the third quartile is 17 plus 18 divided by 2. So third quartile is 17.5.